Okay, let's look at this problem. Mordecai is standing in the middle of the park. Rigby's 100 feet east of Mordecai. So here's Mordecai, and Rigby is east. Mordecai starts running north at 20 feet per second. And then 15 seconds later, Rigby starts walking south at 5 feet per second. And the question is, how fast is the distance from Mordecai to Rigby changing at the moment when Mordecai has been running for 20 seconds? All right, let's finish this picture up first. The distance from Mordecai to Rigby is this. I'm going to make this slightly longer. And what I need to do, instead of putting M and R there for where they start, let's make R and M be the distances that they've covered. So this distance here is going to be M. This distance here is going to be R. And the other thing we're given is they started off 100 feet apart. So this distance across here is 100 feet. So the key to doing this problem is realizing that we can complete this into a triangle here so that we have one big right triangle. And now we can use the Pythagorean theorem on this. Tell you what, let's redraw it. If we just look at the big right triangle, this side over here, the length is 100, and the length of this side over here is M plus R. So let's look at what we're given and what we're asked to find. Let's see. Rigby, let's do Mordecai first. Mordecai starts running north at 20 feet per second. So dm dt is 20. Rigby is walking at 5 feet per second. Let me do that in a different color. So dr dt is 5. Now, if we wanted to, we could combine r and m into a single variable just for this side of the triangle. But let's keep it separate. And what they ask us is, how fast is the distance from Mordecai to Rigby changing? So if we call this distance over here d, we're asked to find how fast is this distance growing at the moment when Mordecai's been running for 20 seconds. So we're asked to find dd dt. All right, and let's see what's going on at that moment. It says when Mordecai has been running for 20 seconds. So if he's been running for 20 seconds and he's going 20 feet per second, that's 20 times 20, which is 400. Let's see, how far has Rigby gone during this time? Well, let's see, Rigby didn't start until 15 seconds later. So Rigby's only been running for 5 seconds. And he's walking, not running. And he's going 5 feet per second. So Rigby has covered the distance 25 feet in the same time that, he's gone 25 feet and Mordecai's gone 400. So we're supposed to find dd dt when this. Okay, well, from the triangle we have here, the relationship between these things is 100 squared plus m plus r squared equals d squared. If we take the derivative of this, derivative of 100 squared is just 0. Derivative of this is going to be 2 times m plus r. And then by the chain rule, we have to multiply by dm dt plus dr dt. And derivative of this is going to be 2d times dd dt. So this is the equation that we need. And we should be able to plug all of this stuff over here all this into it and come up with what this d dt is. All right. First up, I'm going to cancel the 2's. You can divide both sides of this by 2. Get that. So m plus r, that's going to be 425. dm dt plus dr dt, this is going to be 20 plus 5. So this is 25 equals d times d dt. So this is the thing we're solving for right here. We got to figure out what d is, though. And we're not given d, but we can calculate it using this equation here. All right. So when m plus r is 425, you get 100 squared plus 425 squared equals d squared. Let's see. 100, I'm putting this in my calculator. 100 squared plus 425 squared equals some big number. I'll take the square root of that, and I get d is 436.606. And since this is an applied problem, I'm not going to worry about the exact answer. I'm just going to put that in. 436.606. And now I just got to solve for d dt. So 425 times 25 divided by 436.606 gives me an answer of d dt is 24.335. And that's going to be in, what are my units? I'm talking feet per second. So this is also going to be in feet per second. All right, that's it.